Hello students, in this video we'll talk about graph coloring. You already know graph consists of some edges and some vertices. So when we assign particular color to the vertices, alright, so we assign some colors to vertices, we color the vertices as red, green, blue, then that procedure is called graph coloring. Okay, one thing which you should keep in mind during coloring of the vertices is that no two adjacent vertices should have the same color. Okay, so if there is a edge between two vertices, then those two vertices should not have same color, and we should use the minimum number of colors to color a graph, and the smallest number of colors required to color a graph is called chromatic number of that graph. For example, if you have this graph, so how you will color this graph? Suppose I give this vertex 1 as color orange. Suppose I color the first vertex as orange. Now the adjacent vertices to 1 are 2, 3 and 4. So 2, 3 and 4 cannot be given the color orange. Okay, but this 5 can be colored as orange, right? So let's see what can we do for 2. We'll give another color to 2. Let's say we give color yellow to 2. Now after 2, let's see for 3 cannot be colored orange, 3 cannot be colored yellow, because 3 is adjacent to 1 also and 3 is adjacent to 2 also. So we'll give another third color to third vertex, so we give it red color. Now let's see for vertex 4 vertex cannot be colored as 1 orange because it's adjacent to 1. 4 vertex cannot be colored as yellow because it's adjacent to 2, and 4 color cannot be colored as red because it's adjacent to 3. So we'll give a new color to 4. Let's say blue color is given to 4. Okay, so now the fifth vertex. Now fifth vertex cannot be colored as red, fifth vertex cannot be colored as blue, fifth vertex can be colored as orange, right, because it's not adjacent to 1. Fifth vertex can be colored as yellow also because it's not adjacent to vertex 2. So we should use minimum number of color. We can also use another new color, fifth color here, but we should use minimum number of colors here. So we'll use either orange or we'll use either yellow. So colored it as orange. So this is how we have colored the 5 vertices of this given graph. This is called graph coloring. And then this chromatic number. The chromatic number is denoted by chi of g. So chi of g for this graph is 4, as we have used 4 colors, orange, red, yellow and blue to color this graph. So chi of g for the above graph is 4. Now let's see for the bipartite graphs. Bipartite graphs, you already know, are those graphs in which the vertex set are divided into 2 subsets, right? So here you can see this subset is we have this subset and we have this subset. This vertex is attached to other 2 vertices. So if I give a color 1 here, then this color cannot be used in this vertex and this vertex, but the color used here can be used here and can be used here. So only 2 colors are required to color a bipartite graph. So to color a bipartite graph we need only 2 colors like this, like one vertex set will be given the first color, like here I have given red. The other vertex set will be given yellow color, like here I have given the yellow color to this vertex set. You can see the adjacent vertices don't have same color. Here I have red, here I have yellow. Okay, adjacent vertices don't have the same color. So the minimum number color are used here and all the vertices are colored. Now let's see for K5. you already know all the vertices are attached with each other, so one color cannot be used. We need 5 color to color K5, because for all the vertices we will be using different colors. So to color K5, we need 5 color. So here is the coloring of K5. We have used 5 different colors to color K5 because all the vertices are adjacent to each other. So this is coloring of K5. So such kind of graphs, it was very easy to see how to color such kind of graph like bipartite graph, K5, okay, and the first example which I have taken. But what can you say about such kind of graph? How you will color this graph? I think you all should pause the video, take the screenshot and work on this example, and then continue the video to get the answer. I think many of you must have get different answers like 3, 4, 5, 7, okay, because there are 11 vertices here, so you all must have got different kind of answer, and it take long time to process which color to be used on which vertex, right? So there is an algorithm to make things faster and correct. There is an algorithm to color this kind of complicated graph, and that algorithm is called Welsh-Powell algorithm. So we'll follow this algorithm to color this kind of graph. So Welsh-Powell algorithm. So the following steps will be used in Welsh-Powell algorithm. So step 1 is find the degree of each vertex. So we'll firstly find out the degree of each vertex in the above graph. So here you can see degree of A. We'll start with A. Degree of A is 2. Okay. Degree of B is also 2. Degree of C is 1. Degree of D is 1, 2, 3. Okay. Degree of E is 2. Degree of F is again 2. Degree of G is 3. Degree of H is 1, 2, 3, 4, 5. Degree of H is 5. Degree of I is 1, 2, 3. Degree of J is 1, 2, 3. Okay. Degree of K is 1, 2, 3, 4 and 5. So here is the degree of all the vertices of this given graph. Let's see what's the next step. Step 2 is list the vertices in order of decreasing degree. So we'll write that vertex first which has the highest degree. So among these, which vertex has the highest degree? H has the highest degree 5 and K has the highest degree 5. So we'll write them first. H and K will write first. After H and K, 4 degree. Which vertex has degree 4? D. Okay, only D has a degree 4. So next is D. Then 3 degree. Which vertex has a degree 3? G, I and J. So we'll write G, I and J. And after that 2 degree A, B, E, F. So we'll write A, B, E, F. And finally 1 degree is only C have 1 degree. So finally C. So step 2 is complete. Step 3, color the first vertex with color 1. So in this sequence we'll color the first vertex as the one color. So first vertex is H. So we'll give color red to this vertex H. We'll give the red color to this vertex H. Next step, move down the list and color all the vertices not connected to the colored vertex with the same color. Okay. So we'll color all those vertices according to this list. so that no two adjacent vertices have the same color. So after H I have K in this list, but K is adjacent to H, so red color cannot be given here. After K I have D. D is not adjacent to H, so D can be given the color red. After D I have G, but G is adjacent to H, so it cannot be colored as red. After G I have I is again adjacent, so it will not be colored. J again adjacent, not colored. A again adjacent, so it will not be colored. Then after A I have B, but B here is adjacent to D, so D is colored red, so this B will not be colored red. Then after B I have E. E can be colored red because it's not adjacent to H, it's not adjacent to D. Then after that I have F. F is adjacent to E, it cannot be colored red. After that I have C. C is again adjacent to D, it cannot be colored red, right? So next step, repeat step 4 of all uncolored vertices with a new color in descending order of degree until all the vertices are colored. So we'll repeat the previous step with a new color. So after H I have K. Okay, so I will color K with a new color, right? So I give a color, yellow color here to this K. After K I have D. D is already colored. After that I have G. G is adjacent to K, so it cannot be colored as yellow. After G I have I can be colored yellow. After that I have J. J cannot be colored yellow because it's adjacent to K. Then I have A can be colored yellow. Okay, then after A I have B. B cannot be colored yellow because B is adjacent to A. After B I have E. E is already colored. After that I have F. So F can be colored yellow, right? After that I have C. C can be colored yellow. Okay, so only 3 vertices are left now. So we'll take a new color, and all those 3 vertices are not adjacent to each other, so they'll be given a third color. So green color is given to all these 3 vertices. So in this way all the vertices are colored now. So this is Welsh-Powell algorithm, and it is used to color such kind of complicated graphs. So this graph is 3 colorable because only 3 colors are being used to color this graph. Thanks for watching this video. I hope you liked it. Have a good day. Thank you.